Hi, this is Mrs. Slater, and today we're going to do rational equation. 4 things that I would like you to know is first what the definition of rational equations is, and that's going to be equations that contain one or more rational expressions. So we're dealing with lots of fractions. Number 2, what I'd like you to know about this is we're going to multiply both sides of the equation by the least common denominator, or LCD. The reason is because the LCD is going to clear the fractions. And just a skill from pre-algebra that you would have seen before is taking 2 fractions and you set it equal to 6x squared. The least common denominator for this is 20x squared. And if I multiply through 20x squared to each one of them, it will cancel the fraction. So multiply by each one of them. Okay, and then also the last thing is 0 a possible solution of 3 over x? And the answer is no, because 3 over 0 is undefined. It has no meaning. So we got to be careful there when we check our work, just to make sure there's no zeros in the denominator. Example 1. The least common denominator for this one equals 6, because we have a denominator of 3, 2, and an invisible 1 underneath the x. Alright, and I multiply all those together and I get 6. Sometimes that works, sometimes you can get a lower number than that. So I'm going to multiply by 6. And then when I multiply by 6, it actually is x over 3 times 6, which the 3 is going to cancel out the 6 and make that 2. So instead of all that mess, I'm going to erase that and put 2x, because that's what happens when you multiply by 6. Okay? And then the next one is 1/2 times 6, which is really just 3. And again, I can do some mental math there and just put 3. And the last one is 6x. Now it just becomes a solve for x problem. So we're going to add 6x to both sides, set it equal to 3, and then divide. Now there are no x's in the denominator, so I do not have to worry about a 0 being there and being undefined. So let's go on to the next one. On this one, the LCD is x. The denominators are an invisible 1, an x, and another invisible 1. So if you multiply all those together, you get the LCD. And by multiplying every single term by x, I'll be able to eliminate the fraction. Now this is another way that you may want to choose to write it. If I have to multiply everything by x, then I can actually show here that I'm multiplying everything by x. First one would be x squared. The second one, the x's cancel, giving you just 3. And then you have 4x. So now we have no more fractions, and we can't solve the way it is, so we're going to have to move everything equal to 0 and factor. And there are factors of 3 that will give you 4, which are 3 and 1, both minus, and so x is going to equal 3 and 1. And if I take 3 and 1 and plug it back in to this x value in the denominator, they both are going to work. For example, 3 plus 3 over 3 equals 4. 3 plus 1 is 4, so I know that that checks out and is correct. The other one, 1 plus 3 over 1 equals 4, is just 1 plus 3, and that also equals 4. So I know for sure I get the right answer. Okay, the next one, the LCD, is going to be 5x, because x and 5x and the invisible 1 are the denominators, and they all go into 5x very nicely. So I'm going to multiply every single term by 5x. So what ends up happening on this one, the x's will cancel, leaving me with 10. The 5x's will cancel, leaving me with just 1. And that's going to be set equal to 5x. So after combining like terms and dividing by 5, I get 11/5 as my answer. Again, check to see. Nothing's going to affect the x's. It's not going to be undefined. So I know that I am done. Okay, example 3. The LCD for this one is going to be x minus 1 and x minus 2. So I'm going to multiply each term by that. And cancel where needed. So by multiplying by the LCD, remember that it's going to wipe out the fraction. So watch this. X minus 1's are gone. The x minus 2's are gone. And all of the denominator and the numerator are gone for the last one. So we end up with 2x minus 3 equals 1, 2x equals 4, and x equals 2. Okay, so if I take the 2 and plug it back in all the places in the original red problem, 2 minus 1 equals 1, but right here you're going to get undefined. So 2 is considered an extraneous solution. So if that happens, I don't want you to erase everything. Just keep this and just say it's an extraneous solution or cross it out like that. Okay, and then the next two, you can do one of two things. The LCD is 3x, so you can multiply both by 3x. Now some of you may recall that this is just cross multiplication, so you may do that as well. So I'll go ahead and finish this way. X's are in common, 3 is equal to 3's were in common, and it's going to be equal to 2x. X is going to equal 3 halves. Now, if you like to cross multiply better, let me go ahead and get back to the original. So we don't need the LCD if we are going to cross multiply. So it'd be like this and this. 2x equals 3, x equals 3 halves. So you can pick which your favorite method, and you can only do this when there are two terms. Above, we cannot do this because there are 3 terms. 1, 2, 3. And here we just have the 2 terms. So I want you to go ahead and solve the next one, and then we'll go over that in class. And then for the next one, LCD, we're going to do one more together, and the last one is going to be on your own. The LCD for this one is going to be x and then x plus 5. So all this one is going to we're going to multiply by the LCD, so both of them, and the LCD here is x plus 5, and the LCD here is x plus 5 here as well. So the x plus 5's will cancel, the x's will cancel, and all of them will cancel here, leaving me with x squared plus x plus 5 equals 7. Can't solve the way it is, we're going to set it equal to 0. And factors of 0 that will give us 1 are plus 2 and a negative 1, giving the answers of negative 2 and positive 1. So when I plug negative 2 in the x spots here in the denominator, I do not get any undefined answers, so that's good. Same with the 1. I'm not going to get any undefined answers as well. So make sure you're checking on this example that you're doing on your own. And it looks like that concludes our lesson for today.